Grade 12 Physics, Quantum Note number 3, Compton Effect and Momentum of a Photon. In our last lesson, Einstein showed that in the photoelectric effect, photons can act as a particle. In this lesson, we're going to figure out that if light can act as a particle, would it be able to collide like a particle? Yes, it would be. In the early 20th century, Arthur Compton was actually able to show this in the lab. He had a photon come in and collide with an electron, just like two pool balls in an elastic collision. After the collision, the photon will go scattering off with a little bit less momentum or a little bit less energy. That would be shown by that photon having a lower frequency, therefore maybe shaded a little more red in color. And then the electron now has some kinetic energy. If we actually want to calculate the momentum of a photon, we start with Einstein's equation. Let's multiply both sides by v. That way we get an mv, which we can insert p for our momentum. If we simplify and rearrange for p, we should be able to get an equation for the momentum of a photon. We need to do it this way because a photon essentially has no mass, so we have to relate momentum in a different way. So here p is equal to hf over c, or from the universal wave equation, f over c can be subbed in as 1 over lambda. So momentum equals h over lambda, where p is the momentum, h is Planck's constant, and lambda is the wavelength of that photon. Let's use it in an example. Let's calculate the momentum of a green photon. Let's say the green photon here has a frequency of 5.71 times 10 to the 14 hertz. First off, we know in our new equation we actually need a wavelength, not a frequency. So let's calculate that wavelength. Wavelength from the universal wave equation is c over f. So we insert our values and we get a wavelength of 525 times 10 to the negative 9 meters, or 525 nanometers. Now we put in our new formula, h over lambda, and we find that this photon has a momentum of 1.26 times 10 to the negative 27 newton seconds, so pretty small.